fabulous chemistry minions
It is MoNaCo.
and Milks.
We are in our third video in organic chemistry. It's the tip of the iceberg. So
Yeah, some of the basics on page 5.
There's no practice related to this because these are facts.
Yeah, let's just kind of get some of the basics down so we can move on and start building.
And it all is based on carbon. Carbon is really special.
This is really like carbon chemistry, this whole unit.
Mm-hmm.
And part of the reason why carbon is so special is because it
Forms 4 bonds. Okay. These are in a tetrahedral arrangement if you think of 3 dimensions, but on paper, 2 dimensions, we go north, south, east, west.
There you go. And the thing is that it always forms 4 bonds.
Not 3, not 2, not 1, always 4. So some possibilities for the way that these forms are called chains. So they can make long chains. So start at 1 carbon, end at 1 billion carbons. It's a straight chain all the way through. We call that aliphatic.
Okay. If we take that chain and loop it around in on each other, we can actually make a ring.
Mm-hmm.
That's called an aromatic.
We're not going to focus so much on rings because they seem to be rare on our tests and exams, but it can be done. You can spend an entire year studying carbon chemistry in college. It's called organic chemistry.
Yeah, 1 and 2, there's 2 full semesters.
And then you can go to a master's and a PhD in it if we wanted to.
Right, so I can take one of those long chains that we talked about. I can take a little mini one and put it on there perpendicularly. We call that a carbon branch.
Kind of like the trunk of the tree is
the
chain,
carbon backbone, right?
And there's branches that come off the trunk of the tree.
Exactly. Make it different. Change it up.
Non-carbon functional groups can be added. So there's a whole reference table that you'll see eventually. We can add nitrogen, oxygen, halogens to carbon molecules, and it allows for more diversity.
Basically,
Yeah.
tons of diversity, talking in the hundreds of billions of possibilities now, all because carbon makes 4 bonds.
Your DNA is unique to you because of carbon chemistry.
Correct.
And 7 billion people on the planet have 7 different billion codes of DNA.
Right. Well, we are what we call organic life forms. We are carbon-based life forms. So,
Right.
pretty much everything in us has carbon in us in it somewhere.
Being chemists, Milks and I wish we could do more with this unit,
Oh, seriously.
but we're going to keep it to the skipping stones, high-level stuff, the tip of the iceberg that you just got to know.
Yeah, seriously. Naming and that stuff. So, review.
Covalent bonding. Non-metals, like carbon, oxygen, hydrogen, nitrogen, all that stuff, will covalently bond to each other. So
Yep.
you and I, are covalently bonded together, so to
Right.
speak.
And we are mostly water. So, in this particular thing, most of these molecules we're going to build are water soluble.
There's a billion trillion exceptions to the rule because there's a billion trillion different ways these carbon molecules can go
Correct.
together. So we're not getting into those.
Right.
Mostly water soluble.
Little review of covalent bonding, low conductivity, melting point, and boiling point.
So most of these molecules you'll see here are either liquids or gases at room temperature, and very few are actually solids, and definitely no crystal structures.
No. And then we also have slow reaction rates, which makes everything a little bit more easily controlled,
Right.
which is something we want in our body, right? All these reactions
Right.
that are going on
Right.
need mechanisms to control them.
I know that in my organic chemistry lab, I hated the fact the reaction rates were slow because my reaction, I'd have to sit there and babysit it for hours
Yeah.
just to get my products to form.
And you could have been doing something else.
But it was easy to control in so much that I was just sitting there waiting.
This is true.
So,
This is true.
there
All
we
right.
go.
Well, here we go.
Different types of organic formulas. There's 3. The first is a structural formula.
Okay.
And these things show you the number of atoms, the number of bonds between those atoms, and exactly how they're arranged in 3-dimensional space.
So basically, this is about the most information we could give you.
These are the best to me. I love
Right.
these.
Because this gives the most information.
How many carbons? How many hydrogens? How many oxygens? How do they connect together?
Where are they in space? That's the key piece, right?
For sure.
Okay, so next is molecular formula. This is something we're all familiar with. It unfortunately only tells us the number of atoms.
Not exactly how they're connected together.
Or which order they're in.
Right.
Or any of that business. And if you look, this is the same molecule.
2 carbons, 5 hydrogens around the carbons, then an OH hanging off the end. Yeah, okay, I guess it's the same molecule.
It is the same molecule. It is actually the same thing. Then there's the
Condensed formula, which are more rare, but you see them on your reference tables in table R or something like that.
Yep.
It tells you the atoms and the arrangement, but it doesn't really go into the bonds necessarily. So if you look at the top picture, you see a carbon with 3 hydrogens around it on the left.
That's why I see CH3.
And then there's a carbon right next to it, literally to the right, with 2 hydrogens on it.
And that's why I see CH2 next.
And then there's an OH hanging off the right-hand side of it.
And then I got an OH hanging off the right-hand side.
So in order of value, it goes structural formula, condensed formula, then molecular formula.
True. As far as, yeah, about as far as informational value.
Right. Because I like a three-dimensional picture of what's going on with these molecules.
And that gives us so much more with all that bonding.
Yeah.
But hey, let's use this as an example to figure out how to name these guys.
So a prefix tells us how many carbons are present in our organic molecule. We look at table P for prefix.
Oh, there you go. And here it comes. So let's look up at our structural formula right now, and I see 2 carbons.
Okay.
So if we look on our number of carbons, I see 2.
Yep.
The prefix for 2 carbons will be F.
F.
Okay?
Okay.
Good. That's the first piece.
Next part, our root tells us what kind of bonds are present. So if I look at table Q, and I see that, well, all the carbons have single bonds between them. So the root belongs to the class alkanes, the name.
Notice in the picture under the structural formula of alkanes, there's a single bond between the carbons.
Right.
There's not a double bond or a triple bond, which is in the others.
It's a single.
It's just single.
So we take the root, and then what do we do?
It becomes F.
Ane.
Ethane.
Ethane, good.
Okay, good, good. And we're not writing this down. I hope you're listening.
Right.
Then number 3, special ending tells us if there's a functional group or not. This is going to be table R.
Right.
And there is a special ending on this molecule. Can you see it, Mr. MoNaCo?
OH. So table R's got an OH. So I'm playing the matching game. I'm looking for OH hanging off the end of something. I see it in 2 spots. I see it as an alcohol, and I also see it as an organic acid. But in our molecule here, we only have the OH. In an organic acid, there's a C with a double bond O at the top, too.
Right,
So-
we don't have that double bonded O, so that eliminates that.
So that means that this must belong to the class of compounds that's an alcohol.
Okay, good. And now let's look under the name of alcohols. I see prop, which is one of the prefixes. I see the
And-
ane, so it looked like it was propane.
Propane.
So what I must have lost the E from the ane and
And
added
the OL.
That would be my special
So
ending.
all alcohols end in all.
Correct.
Ethanol, methanol, propanol, butanol,
Ooh, you said it.
pentanol.
This was F-ane, drop the E, add the OL for the OH, and I get ethanol.
So, check and see if you did your homework. Name it. Write it in the box. What did you say it was, Mr. Milks?
Ethanol.
Ethanol. Ethanol. Good.
Right.
Write that in the box on your lecture so we know that you actually
Now,
paid attention.
we don't need to use this special 4th piece in this particular name, but if there's a number in front of it, that's going to tell us, it's like our map of where all the special things are, be it the double bonds, the functional groups, and the side chains.
Which carbon number in the
Right.
chain
That it
has the
exists.
chunk on
And
it?
now, MoNaCo, why do I not have to put a 1 in front of this ethanol?
Because there's only 2 carbons. And if I flip this, if I put the OH on the other side of it,
I'm not changing the molecule. I just
not
rotated
really.
the thing.
So the first carbon
Has to have it.
has to have it.
Right.
So if you flip back real quick to table, that reference table, see the alcohol here says 1-propanol. So the first carbon in that chain has the alcohol on it.
Right, but that has a middle carbon because there's
Right.
3. That alcohol could have been
Two.
on 2-propanol
Propanol.
and put it on the middle carbon. In this case, I don't have a middle carbon. It's got to be on the end. It's going to be on the end. It's always 1. Just rotating it doesn't.
So in the future, we'll be paying attention to where your functional groups and double bonds are.
Correct.
But for the time being, just know there might be numbers in front of your names.
There you go. Kind of, just a little bit generic.
Recap.
You need to know the basics of carbon chemistry. Specifically, how many bonds does carbon always form?
Quattro.
Quattro.
What reference tables are going to be useful?
Was
P.
P, Q, and R?
Yep, just
P,
3.
Q, and R.
And I want you all to start looking for naming and structure patterns because that's what this unit's really going to be about.
Right.
Name, structure, structure, name.
Right.
Back
It's going to be
and
really
forth.
heavy on practice, and you're going to find that once you get a feel for the naming structure and how it's the same for all of them, it's going to start making sense, and you're good.
Thank you, young Padawans.
Keep on learning.